Have you ever made a graph only to be frustrated that all the points don't fall in a nice, neat line or pattern? How tempting it is to just average them into one nice number and be done. I hope this video will help you see just how valuable it can be to keep looking at data points as they are naturally distributed. Analyzing data is all about making sense of measurements of groups of things. Most groups, such as the sizes of fish in a lake, inherently vary. They might vary a lot or they might vary a little, but at least in a natural setting, it's unlikely that all of the fish would be precisely the same length. Variability is natural. Variability is a property of a group. Variability arises out of a collection of measurements. One of the fun things about analyzing data is looking for patterns and variability and interpreting what those patterns mean about the phenomenon or process you are investigating. How can you graph a collection of measurements to show and describe how they vary? Let's explore a question about how much electricity varies in households. So this is how much electricity households tend to use each month in different U.S. states. I expect that the average monthly electricity use by households will vary among the states, but I want to look for some clues to help me make sense of how and why monthly electricity use might vary. Each dot in this data set represents a state. In this data set, we show which state it is. If I connect a dot, click on a dot, that's Alaska. It gives me the region that that state is in, whether it's a northern or southern state, the number of customers that were sampled, and the average monthly consumption in kilowatt hours used on average in that state by households. And it also gives the price that customers paid and their average monthly bills. So let's take a look at how much electricity households use on average in the United States, in different states. Right away, I can see that monthly electricity use is fairly evenly spread out. It's pretty much symmetrical. It ranges from the highest in Louisiana, where households average over 1,300 kilowatt hours per month, to the lowest, which is Maine, which households average 521 kilowatt hours per month. That seems like a big range to me. Households in Louisiana tend to use almost 3 times the amount per month as households in Maine do. So far, I've learned 2 things about this group of points by looking at the dot plot. I can see what the range of values is, 827 kilowatt hours from lowest to highest, and I can see that the states are fairly evenly spread out within that range. I can also look at where the center of the distribution is to approximate a typical value. Let's look at the mean. If we show the mean, it falls in the middle of the data set, and the mean points to where the distribution is centered on the scale. If we were to summarize the whole group using just the mean, it wouldn't represent the whole group of states very well. We would have no idea whether states are clustered around the mean or whether they're spread out as they are. So from just the mean, we just can't tell very much about the group of points. If we change this to a box plot, and I'm going to keep the dots there so you can see where the box plot falls. The box plot gives us an idea of where the middle half of the data points fall within this box. The points in this section are the lowest 25% of points. The points in the first part of the box are the second 25%. The third 25% are in this section, and the the upper quartile, or the fourth 25% of points, are in this whisker. So the middle half of the data points fall within this box. And that's a pretty good way, informally, to decide what's typical. What's typical monthly electricity use for households in different US states? Notice that the middle line here is the median, not the mean. So the median is the middle data point. So the wider the box, the more spread out the points are. If the points were clumped right around the median, this box would be very narrow. So far, I don't yet have a sense of why electricity use is so variable among the states. I'm going to go back to the dot plot for a minute. And I don't see any strong clumping here that gives me any clues. So let's see if northern or southern states have different amounts of electricity use. So by putting northern or southern on the y-axis, I can see now that the southern states, there's a clump of states here that have a rather high amount of monthly electricity use. Are these two distributions different? What would you say? I would say this one's dragged a little, offset a little bit to the right. The means are certainly quite different. The ranges are similar. This one has a little bit of a bigger range. So the distribution of southern states is now asymmetric. It's got this clump here with a long tail of points going out to the left. The distribution of the northern states is still fairly symmetrical. So it looks like, so what is this clump about? Can we find a reason for this clump? If we click on US region, we now can see that these points are all either in South Central or South Atlantic states. Most of these points here are from one of those two regions. And if we click on New England states, we can see that all the New England states fall below the mean for northern states and use among the least amount of energy per month. So from these patterns, I'm beginning to get the sense that hot places tend to use more electricity per month on average than cooler states do. Possibly that's due to the need for air conditioning. I can put US region on Y to get a more precise view of what's going on. So it looks like states in North Central and Pacific regions have more variable monthly electricity use. And it looks like states in New England, these states, and the states in South Central US, those have much less variability in the amount of monthly electricity use. Maybe this has to do with the variety of climate zones in the North Central and the Pacific regions, such as elevation or proximity to the ocean. We can just take a guess at that. So there are other ways to visualize and describe variability, either informally or more quantitatively using statistical measures. This is just an introduction to the idea that variability is an inherent property of data, and that trying to explain or account for variability in data is all part of the challenge and fun. So in summary, visualize variability by looking at distributions of data. Describe distributions by their range, their general shape, and where their center is, and pointing to where it falls on the scale. And Look for patterns in distributions of data and try to explain what factors might be causing a group to vary the way it does. Now it's your turn. Open the household electricity consumption by state dataset in Tuva, read about the dataset, and review the attributes. And now I'd like you to create distributions to show the variability in average monthly electricity use, also in price per kilowatt hours and or average monthly bills for the states. And see what sense you can make of the distributions and the variability that you find. Describe the variability, highlight or filter or add other attributes to the y-axis to help you explain possible reasons for the patterns you see. Oops. And what can you learn about electricity cost and use in different states or regions based on the distributions that you've created? Have fun exploring the data.